Okay, so for problem 1122, they're identifying we're going to have two sprockets for a number 80 chain. One has it having 19 teeth and the other 64 teeth. So they've already identified the number of teeth and the chain that we're going to be dealing with. The chain has 140 links. Okay, so we know how large it is going around. So if we look here, let's just go back to page 310 here. They've told us already how many number of teeth are on this pinion and on this pinion. So smaller, larger. And then how many links are on the chain going around. Okay. So that's already given for us and the size of the chain. They want us to determine the pitch diameter of each one of those sprockets. That's going to be our D1 and our D2. The center distance and the angle of contact over the smaller sprocket. Also compute the center distance, also compare the center distance to the ideal range. Okay, so. Let's start off because they kind of gave us a nice little list here. This is problem 11-22. And what's given in this problem is we're given the chain is equal to number 80, okay? We're also given the number of teeth on the smaller gear, or the input gear, is 19 teeth. The N2 on the larger, I shouldn't say gear, they're sprockets. They're sprockets when it's chains. 64 teeth. They're kind of like gears. They're very, very close, right? And then our L, the length of the chain, is going to be 140 links. Okay, 140 links. And we want to find, okay, we want to find D1, D2. We want the center distance. Okay, and the angle of contact of the smaller sprocket. Now, I will tell you this, angle of contact we did not do in any of the examples, but I did show you, and we will look at where that equation is. So it's not hard to do. It's just really a plug and chug. So I'll revisit that at the very end. Okay, so first and foremost, we're going to start off by calculating these diameters, the pitch diameters of each one of our sprockets. So we're going to go back in the chapter. On page 311 are all the equations that you need, okay? So this is page 311, and the very first equation up at the top here, equation 1110, is the pitch diameter equation. So we're going to do that twice, once for D1 and once for D2. So D1 is going to be equal to the pitch divided by sine times 180 divided by the number of teeth, and this is degrees. Okay. Now, pitch. We don't have a pitch given up here, but we know the number of the chain. So our P is going to be 80 divided by 80. Okay. So our pitch then, our P is going to be equal to 1 inch. Okay, 1 inch. That's what the units are for pitch. So it's the number of chain, the chain number divided by 80. So it's 80 divided by 80. So our pitch that's up here, that's going to be 1 inch. Okay, and then our number of teeth, because this is the pitch diameter 1, this is going to be number of teeth 1. Okay, so D1 is going to be equal to 1 inch divided by sine times 180 inches. And this would be our teeth. This is inches. Remember, if you remember, it's inches per tooth. Sorry. We went over this, I know, in our overview. And then this is going to be the number of teeth is 19 teeth. So our tooth and our teeth cancel each other out. Tooth is just singular, obviously, of teeth. So our D1 is going to be, there we go, here it is. .076 inches. Now, in this case, we're not going to a chart to pick one off because we already know that it's a number 80, 19 teeth, and we're just calculating the corresponding pitch diameter. Okay, so this is going to be the pitch diameter 1. Okay, so that takes care of our first item. Now we're going to do that very same thing for pitch diameter of 2. So P divided by sine of 180 divided by number of teeth 2. That's going to be equal to 1 inch per tooth divided by sine times 180 divided by 64 teeth. You cancel out. 6 degrees. Going to be a decimal underneath. So our D2 20.38 inches. So I'm just going to grab the chat out really quickly. So as you're following along, Noble, do you get the same numbers as I did for those? Just want to be sure I don't want to go too far ahead if you're still calculating. Okay, perfect. So we got both of those. Then the next thing we're going to do is we're going to calculate the center distance based on the number of links and our pitch diameter. So let's go back to page 311. So if we didn't know how many links our chain needed to be to go over the top of each one of those sprockets and maintain a certain center distance, we would have to use this equation. But we've got the number of links already, so we can go right down to the center distance right here. Okay, so I'm gonna go on to my next page here. So my center distance is going to be equal to, and this is that really long equation. It's going to be P divided by 4 times L minus N2 plus N1. I would suggest doing this in kind of phases because it's long. And I'm going to try to get my bracket on the outside here. So now we're going to put our values in. Okay. Now, this was the equation I told you. This one's really long. Don't worry about units because you're probably going to take 3 lines to get all the units in and write them out. So just do numbers here. So my P is going to be 1 inch divided by 4. My L, that's the number of links in the chain. And it says that that's 140 minus N2 64 plus 19 divided by 2 plus, this is the big one. So this is going to be 140 minus numbers in there. Now I've got to figure out what I got. So I'm going to start kind of on the back end here and put my numbers in, and then I'll add together. So it's going to be a little bit of a work in progress. able to do. We got a center distance. I did it just once here. But did anybody else get the same value? Or maybe Noble, you're the only one following along with me. Okay, one sec, no problem. Take your time. I know it's a long one. We had a different number for the 12. Okay, all right, let me recalculate mine. What did you get? Oh, I know what I didn't do. I know exactly what I didn't do. I know what I didn't do. Square divide. Did you get 2,184? Oh no, wait a second. All right, let me try again. Let me try again. No, you know what I didn't do? I know I didn't square my pi. I know I didn't. So let me try it again. Minus. So rid of that. That is so easy to forget. And I even like try to remind you guys, and then I end up doing it. Square. Yep, 410.35. Okay, so let me recalculate because that means that this number is not the same. All right, so 48.72. Is that what you got for your C? Yeah, make sure you square that. That makes the difference. That makes the difference. Oh, you didn't get that. Okay, let's try again. Oh my goodness. I don't claim to be perfect. 5410.35 plus. I will do this. Oh my goodness. Try again. 02.25. All right, this number I'm pretty darn sure about. It's close to my other one too. You got 98.7. Oh my goodness. Oh, that might also be, are these numbers the same as yours? I know this one's the same, right? This is probably close. Let's double check. 40, 64, 19 plus 2. Yeah, 98.5. Maybe a rounding difference. There must be, yeah, because I got this twice. So I'm pretty confident 702.25 and 410.35 plus square root, yeah, plus 0.25 times. Yeah, I've gotten this, yeah, 3 times now. So you're right, maybe a rounding area. But the good thing is that you're going to notice that now there is an equation on that same page. It's not an equation, it's just it's in there, not listed as a formal equation number, but you're going to take 30 times the pitches, which is 30 times 1 inch, and that's going to give you 30 inches. Your center distance needs to be greater than 30 inches, but less than 50 times the pitch, which is going to be 50 inches because our pitch is 1 inch. So this is our range. So that what that means is when we compare it, say center distance equals, you could say good, because it falls in between these two numbers. Okay, and that's what it means by compare it to the ideal range. This is your ideal range. Okay. And that should be all that you need. Oh, there is one more thing. There is one more thing in this problem. It is asking us for the angle of contact on the smaller sprocket. So we do need to do that. So I don't want to forget that. So let's see if I'm on a number. So this was step 2. So step 3. Okay, so angle of contact, that was not done in either one of our examples, but I did point it out for you guys on that same page, 311. Here are the angle of contacts for the sprockets. And our smaller sprocket is going to be theta 1. See, theta 1. So here is the equation for the angle of contact. So equation 1113, this is the one that we want to do for the smaller sprocket. So this is going to be theta 1 is equal to, we're going to get 180 minus 2 times sine to the -1. So that's going to be the inverse sine times p times n2 minus n1 over 2c. So it's going to be 80 minus 2 sine minus 1 times 1.0 times number of teeth. 2 was 64 minus 19. Sorry. 19 divided by 2. And our center distance was 49.77 inches. So our theta 1 I got 126.2 degrees, which I believe is the correct answer. I'll do it one more time. Now, yours is going to be a little different just because your center distance was different than mine. So I had 49.77, you had the 48 point something, right? 48.7. So that'll make that a little bit different. Yeah, I got the same number each time. So then that would be the end of this problem, is the angle of contact, theta 1. So did that one come out for you, Noble? Once you get done. Yes. Okay. Yeah. And again, yours is going to be a little bit different here because of the difference in that center distance value. Okay. All right. So that takes us to the end of that problem. Now, those are the elements in 1122.